I'm gonna cry.
I didn't say I was gonna cry. I just said gonna cry.
Oh, my bad.
I didn't think back then. You know, he can. How funny would it be if I could just fake cry and I start sobbing? Like Marissa. Yeah, she scares me when she does that. Her face gets all red and like it looks so real.
She did this to me during weights because she didn't want to squat. I was like, Marissa, you're not getting out of it.
You're like, put on the squat belt and squat. Okay, so on 7.4.
Wait, I need to get my notes out.
Gotta play the calibration game here.
Oh my god, that was so bad.
Oh, it does.
What?
You sound like an animal. You're not anyone, but you still sound like one. Like the thing you run
Hey, I
over
think
the
so.
car and you just like.
This is the
what
fastest
was
I've gone
that?
through this yet.
Godspeed, console.
Hey, thank you.
And that sounds like what you do whenever you realize you hit something.
Precision,
Swerve over.
Accuracy and speed. I'm like Lightning McQueen up here. Oh man. Okay.
Oh, wait,
Bless you,
the
unless we don't
cow.
have to, unless we forget. Hey,
You
so
gotta say the cow.
7.4, we talked about a monomial. What was a monomial? We said it's a number, variable, or a product of a number and one or more variables. Mono means one thing, one term. There are no plus signs or subtraction signs. There's no addition or subtraction, and we do not have variables in the denominators. We said all of this. We said, hey, if it's just a real number, it's just a number by itself, like 3, for example, it's called a constant. So we walked through some examples of what monomials were. We said, hey, all of these on the left were monomials. We said, this is okay because it's a product. There's no addition or subtraction. It's still all one thing together. This is okay because even though there's a denominator, it's a number in the denominator, not a variable. We said this is not okay, not a monomial, because there's an addition. This is not a monomial because there's a variable in the denominator. We walked through all of these, saying, hey, are these or aren't these monomials? Monomials. Phenomena. Okay. Nice. Okay. I didn't expect anyone to catch on with that, so we're happy about that. Okay. So now we're going to learn about a polynomial. Does anyone know what the prefix poly means?
Two. More. Multiple.
Many or multiple. Poly means many or multiple. Okay. Mono meant one. So monomial meant one term. Polynomial is going to be many terms. So a polynomial.
Those. Like monotheism, polytheism. Two numbers.
A polynomial is a monomial or a sum of monomials. So it can just be one monomial. It can just be one term. But it also can be multiple terms. So now we can have the addition or subtraction in there. We couldn't have the addition or subtraction before with just a monomial. But we can have addition or subtraction with polynomials because it separates them into each monomial. So if we have the sum or difference of two monomials, we're going to have binomial.
Wow, I had no idea.
There we go. There's two.
There
That's
we go.
the word.
What would we call it if there's a sum or difference of three monomials? Oh, man. Too good. Trinomial.
Because bar means
Can't stop, won't stop.
Wait, hold on. Does that mean whenever you get like 10, would it just be like
Decanomial? No, we don't call it a decanomial. If we go with polynomials with 3 or more terms, they don't have special names. So we just call it like a 10-term polynomial, or a 4-term polynomial, or a 5-term polynomial, or a 6-term polynomial, or a 7-term polynomial, or an 8-term polynomial, or
an octanomial.
Is that getting old? Yeah, I was getting old saying that too. Okay, so here we have some examples of monomials, binomials, and trinomials. These are all considered to be polynomials. They're all considered to be polynomials, but these are just more specific kinds. So a monomial, one term. So notice there's no plus or minus signs. It's just one product and one product. A binomial, all of a sudden, is 3 a monomial? 3 itself is a monomial. Is 4a a monomial? Yeah, but we're adding them together, so it's 2 monomials. So we call it a binomial, because there's 2 of them. Or here, on the left, 7CDE is a monomial. On the right, CD squared is a monomial. You add them together, and it's called a binomial, because they're separated by the plus sign. A trinomial, A is a monomial, B is a monomial, and C is a monomial. But A plus B minus C is a trinomial, because it's 3 different monomials separated by this addition and subtraction. So we have our polynomials, our monomials are separated by addition and subtraction. We have the same thing here, trinomial. Now notice, do we have any variables in the denominator on these? Do we have any variables in the denominator, in the bottom part of the fraction on these?
Is there any part where it could be a fraction?
No, there's no fraction on these, but there's no variables in the bottom because we still can't have variables in the denominator for a polynomial. That still can't happen. Still can't happen. So we're going to state whether these are a polynomial, whether each expression is a polynomial, and if it is, we're going to say is it a monomial, binomial, or trinomial. And we have to be sure to simplify first if we can. So we look at number 1 here. 3a minus 7bc. So we want to look at this. Is there anything that makes this not a polynomial? Well, the thing that makes it not a polynomial is that there's a variable in the bottom. Is there a variable in the bottom? No. So, first of all, yes, it is a polynomial. Now, in the English language, a semicolon means that you said something, but there's a little more to follow before the sentence is over. There's a little more explanation. So, yes, but what kind of polynomial is it? A binomial. How do we know that, Rowan? There's 2 terms, and we notice where the terms are because they're separated by a plus or minus sign, by addition or subtraction. So here, there's a subtraction sign, so each of these are monomials, making them 2 binomials. Number 2, is this a polynomial? Are there any variables in the denominator? No, so yes it is a polynomial. But can we simplify this?
Yeah.
What can we simplify?
Add 7a and a.
Ah, 7a and a. We have like terms. What do those become? AA. We add them up. So we still have everything else the same, like 3x squared plus 8a minus 2. So yeah, it's a polynomial. And what kind is this? A trinomial. How do you know it's trinomial, Jackie? There's 3 terms here. There's 3 terms here. Now, if we had done this before simplifying, what would we have called it? We would call it a 4-term polynomial, right? But is that the same thing that we got after we simplified it? No. So we've got to be careful to simplify, because we can get a different thing. It's still a polynomial, but it's a trinomial instead of being a 4-term polynomial, because we were able to simplify 2 of the terms together, 2 of the like terms together. The same variable being raised to the power of 1. On the third one, is this a polynomial? No, why not? Tyson, you're shaking your head no. Very good. We have this variable in the denominator. So no, it's not even a polynomial. So it can't be any of these more specific kinds of polynomials because it's not one to begin with. Just like, I don't play basketball. So can I be a point guard? No. Point guard's a position in basketball for those that might not know. I can't be a point guard if I don't play basketball, because I don't play basketball. Now, Austin plays basketball, but is Austin a point guard? Yeah, totally. Okay, right? No. What are you? Okay, a center. So it's different. So I'd be like saying, yeah, this is the binomial and this is the trinomial. They're both polynomials, just like Josh and Owen might both be basketball players, but they're different positions. One's a binomial here, one's a trinomial here. But me, I'm not even a basketball player, so I can't even be classified into any of the positions. Does that make a little more sense, maybe? Okay, Dank. Questions on this before we move on to right below this? So, we're going to talk about degree. So what is a degree? The degree of a monomial, remember 1 term, the degree of a monomial is the sum of exponents of all its variables. The sum of exponents of all its variables. What's sum mean? What operation does that mean? Addition, awesome. So we're going to find the degree of a monomial, we'll add all of the exponents for the variables. Now, if we have a polynomial, multiple terms, more than just one, it's going to be the largest, and make sure I use the exact word here, so I don't confuse people later. The largest degree of any term in the polynomial. The degree of a polynomial is the largest degree of any term in the polynomial. Now, the term in the polynomial, term is just another word for monomial. Term is just another word for a monomial in that. So maybe write that in and say, hey, that's what term means. It just means a monomial. Now, in order to know the largest degree of each monomial, which one has the largest, you have to find the degrees of the individual ones first, like it says here. In order to compare, you have to find the degree of each term first. But we're going to walk through that before just saying, hey, let's throw you to the wolves and have you do some homework over it. So on 1, let's find the degree of the monomial. Okay, first of all, yes, it is a monomial. There's no addition and subtraction. So it's only one term, and there's no division of a variable. There's no variable in the bottom. How many variables do we see here? 1, just y, right? Okay. What power is y being raised to, Kennedy? 3. So this means this has a degree of 3 because we added up all of some of the exponents of the variables. Only one variable, so it's just 3. On number 2, how many variables do we have here, Riley? 3. We have a, b, and y. What power is a being raised to here, Owen? A. 1. I think, yeah. What power is b being raised to? 1. And what power is y being raised to? 2. So what would be the sum of the exponents of the variables? Rachel? 4. How did you get 4? You added 1 plus 1 plus 2, and you get 4. So notice we didn't add the degree of the constant of the coefficient of our number. We just added the variables. And we said, okay, if we don't see a variable here, if we don't see an exponent on the variable, it's really just an exponent of 1. We have to remember that. We don't just want to call it a power of 2, a degree of 2. Instead, it has a degree of 1 plus 1 plus 2 is 4. So on 3, do we have any variables? So if we don't have any variables, what do you think the degree of this is going to be? 0. I saw some hands go up saying 0. It's going to be 0. If we think about that, what is anything raised to the power of 0? 1. Awesome. So if we have anything raised to the power of 0, that'd be like negative 14 times x to the 0. And what would x to the 0 be? 1. So that'd be just like negative 14. Which is what we have. So if that helps us, we can think of it, there's kind of like an x to the 0 being multiplied with it, but that's the same thing as 1. Tyson, head up, please. On 4, 4 squared ABC. How many variables do we have here, Josh? 3. Awesome. We have A, B, and C, right? Okay. What kind of power do we have on A, Sarah? Awesome. Haley, what kind of power do we have on B? Dang. Rome, what kind of power do we have on C? 1. Gabe, what is the sum of the exponents of the variables? 3. Very good. Why didn't you ask 2? That's not, because 4 isn't a variable. So even though 2 is an exponent, it's not a variable. So this has a degree of 3. Questions on that? Okay. So find the degree of each polynomial. So moving right below this, to find the degree of each polynomial, we said it's the largest of any term in the polynomial. This has 2 terms, 1, 2, separated by the plus sign. So we need to find out the degree of each of these and compare. So what's the degree of this first one? 2, because the variable has exponent of 2. What's the degree of the second one? 1. Which one of them is bigger, 2 or 1? 2. So what's the degree of this polynomial? 2. You're going to say, which one's bigger? I want you guys to do the second and third one. When you're done, raise your hand, or if you have questions, raise your hand, please. Same. Has everyone had their work checked? If you haven't had your work checked, raise your hand. If you haven't had your work checked, raise your hand. Oh, see a hand up, see a hand up, see a hand up. Okay, we're making sure we're all on the same page here. If you haven't had your work up, if you haven't had your work checked, raise your hand.
I look so tan. Why'd you say you look so tan? Look at it. It looks tan. You don't look tan. You look
Okay, let's go back to our seats.
You look tan.
So here, what's the degree of this polynomial in number 2? 3. How do we know that? Because it's the biggest degree of any of these terms. This one has a term of 3, 2, 1, 0, so 3 is the biggest. What about number 3? It's 4. Because the second term here, the middle term, has a power of 4, a degree of 4. Whereas the first one has a degree of 1, third one has a degree of 2. And last I checked, 4 is bigger than 2 or 1. Questions on this one? Awesome. Last thing I want to work on for this section is we need to rewrite these in what we call standard form. Mr. Castle, what's standard form? I don't know that. Well, good, I'm going to teach you. What I mean by standard form is I want you to write this in here. 2 things to write in. Is I want you to write that they're in descending order, descending order. And I also want you to write in addition to them being in descending order, is that they're also going to be alphabetical. And by that I mean the English alphabet, not the Russian alphabet, okay? Just want to make sure.
What alphabet?
The Russian alphabet.
What about the Greek alphabet?
Yeah. What
He
about
wrote
the
his
what?
essays
What about
in
the Greek
Russian.
alphabet?
Let's not
Only
go
for her class.
Who's class? Who's Irish?
All
He
right.
wrote all his essays for her class in Russian.
So what's descending mean?
Going down.
Going down, okay? So you start at the top and you go down. And alphabetical means that A would come before B, right? You're gonna order like, you know, A, B, C, D, E,
I know the
F,
alphabet.
G,
Oh,
right?
I count.
Okay, so on this one, we want the descending order of a variable. So first we say, what variable are we dealing with on number 1?
What?
Just x's, right? We don't have any other variables here, just x's. Okay? So we don't have to worry about alphabetical, right? Because there's no other variables to sort. We don't have to say, oh, x comes before y, so we'll put x before y. It's just x's. So now we say we want to put it in descending powers or decreasing powers of the variable. So here, which x has the biggest power? The negative 21x to the third, right? So that's one we're going to put first, because this has the biggest power. This x has the biggest power. So we're going to put this negative 21x to the third. Why does it have to be negative? You got to take the sign with you here. Okay? You got to take the sign with you there. So which one comes next? 18x squared. What sign is going to go between those? A plus sign, because it's positive. 18x squared, because x squared is bigger than no x. And so what would follow that? Plus 30. So this is what we call in standard form. This is our standard form of a polynomial. We put it in descending order so that way we can instantly see, hey, where's our biggest power? Oh, our biggest power on any variable is right here. You see it right at the front and center. That'll help us more as we continue on in further math. And we also want it alphabetical, but we didn't have to worry about that one. We didn't have to sort through any other letters here. So on the second one, we want to write this in standard form. So we want it to be descending and alphabetical. Do you have to worry about alphabetical in this one? No, why not? They're all x's, right? They're all the same variable. So x doesn't come before x, it comes at the same time as x. So descending order, meaning we need these to be in terms of greatest power to least power of x. So what's our greatest power of x? 2. How many of those do we have though? 2. Ooh, so what do we probably want to do with those? Combine them. Very good. So how can we combine these like terms? Since this is x squared and this is x squared. squared, same variable to the same power. Adam, so in this case, 10x squared plus a negative 3x squared is 7x squared. We can say, hey, these are like terms. 7x squared. So we probably want to put those x squareds before the normal x's, right? Because we said 2 was our biggest power. Can we combine other like terms here? Yeah, I think so. Asen, what do you see here? Awesome. So what would be 9x plus a negative x? 8x. So is this now in descending order and alphabetical? Yeah. And we combined everything that we could. We want to look to simplify as much as you can as well. I want you to do that third one on your own. I want you to do the third one on your own. And kind of the same process. Once you have it, we'll raise your hand and check it. Raise your hand if yours hasn't been checked yet. Okay. Hopefully you guys are being honest and making sure everyone got theirs checked. Okay, so this one ends up being, Mackenzie, tell me what it is. Very good. Negative a to the third, or a cubed we can call it, plus 10a squared, plus 2a, plus 17. We had to combine that 7a squared and 3a squared to get 10a squared and put it in our descending order. Questions on that one? Okay. So I have a worksheet here. 12 questions. I think they're pretty quick questions though, because it's just all the same stuff we did on here. The plan is to work on this for about 16 minutes to about 9. 9, okay. We're going to list about 9 here. And then we'll plan to start our other nodes at that time, okay? Questions on that process?
Is this our only homework?
No, but you should, well, you should have
She's getting more and more like hours. Taylor, I actually didn't
By the time we're
realize you were wearing
sophomore,
tights until I saw your
like,
video,
you know,
and I was like, why are you
I'm hoping I'll still have hair.
Yeah, I'm a she is a cool one.
How?
Right.
Why does it fit?
So feel free to set some music up real quick, but I won't spend a whole ton of time setting up your music, okay? And be prepared to take it out when I